Okay, it's recording. Okay, a progressive wave is described as y equal to 2 sine 2 pi, this equation, yeah? And then where x and y are in centimeter and time is in seconds, determine wavelength, frequency, wave propagation velocity, and direction of wave propagation. Okay, so what I want you to pay attention is this part, yeah? He say x and y in centimeter. This one is about unit. Very important, yeah? Very important things. So, and then he says about the time. The time here is in seconds. This is very important. Okay? So I want you to write. Okay, so that means this one, the x is in centimeter, yeah? The x here is in centimeter. Okay, and then the y is also in centimeter. So that means if x is centimeter, x is related to the wavelength. Yeah, x is related to the wave number. Wave number is related to wavelength, isn't it? Wavelength. So what I can say is wavelength also will be in centimeter. Understand? If x is in centimeter, then the wavelength also in centimeter. Yeah, and then the wave number, the unit is radian per centimeter. Okay. And then the y, he say y in centimeter. Y in centimeter, that means the amplitude. Yeah, the amplitude also in centimeter. Okay, if the y is in centimeter, means the amplitude also in centimeter. Okay. And then he said, and then another thing is, he said time. The time here is in second. So that means what? Time is related to what? Time is related to omega, right? Omega. So omega is related to period. So period also in second. If time in second, so period is in second. Okay, the period is in second, and then the omega is radian per second. You know, sometimes things will change. Like the time can give time in millisecond. The time can be in milliseconds, so the period will become millisecond. You understand? And then if sometimes the x here is in meter, so lambda is in meter. Yeah. Or maybe even though if this displacement here it give in meter, so the amplitude will be in meter. So you must be careful with all this. All right, be careful with all the unit. Right now, he said displacement is in centimeter, so you must put the amplitude also in centimeter. The x is in centimeter, so the wavelength in centimeter. And then the time is in second, so the period is in second. Okay, so understand, class?
Yes.
Yes, sir.
Good. All right. So now you have this formula. What's our general formula? Well, general formula is this. Yeah, progressive wave formula. Actually, there are alternative form to get this. Yeah. This formula is actually similar to this formula, isn't it? Similar to this formula, but sometimes the exam doesn't give this alternative form formula. Yeah, it doesn't give you, so you need to derive yourself. Yeah, so the exam, the answers, the question sheet only give you this formula. So use this formula. Okay, y equal to a sine omega t plus minus kx. Okay, and work from there. Yeah, derive on your own. So y equal to a sine omega t plus minus kx. This is a general formula, right? So we very hard to compare with this because not in the same form. However, we can change change it. Learn to change, learn to derive. So A sine omega is, you know, 2 pi over period, yeah? 2 pi over period. And then wave number is 2 pi over wavelength. Learn to derive. Learn to derive on your own. Okay? And then A sine, and then you see here we have 2 pi, 2 pi, so we can factor out the common, yeah? We can factor out the common, 2 pi, factor out, and then left with period below. Okay? And then this one also factor out the 2 pi, so left with 1 over lambda. See that? So now you get the formula in similar form with this one, isn't it? And we can clearly see. What is what. Yeah, what represent what. Okay, so we can. Okay, now we can write the relationship. So from here, sorry, who's coming in? You should actually log in using MOE email, MOE ID. You should actually log in using MOE ID. Okay, so from here we can see. Okay, maybe you can just write down below here. Write the y equal to 2 sine 2 pi, and then what do you have there? 0.40 plus x over 80.0. That's your formula given. So now we can compare. So from here we can see amplitude is 2 cm, right? Why amplitude is cm? Because y is in cm. Amplitude is in cm. Oops. And then we can see period. Period is in 0.4. Is in second. And then what else we have? We have lambda. Lambda is in centimeter also because x in centimeter. Yeah. So lambda is in centimeter also. So be careful with this unit. Very important. Yeah. Very important, this unit. Okay, so we got the answer. So we got A. Yeah, A, we got it. B, do we have it? Yeah. So question A, we got it. The wavelength, question A. Question B. Question B. So question B is frequency. So frequency is actually 1 over period. 1 over period. So it's 1 over 0.4 second. So what do you get? 1 divided by 0.4. 2.5 hertz. Okay. And then question C. Question C, wave propagation velocity. Wave propagation velocity is, you know, this one, right? Velocity of the wave. V equal to F lambda. F lambda or lambda over period is constant value. Remember this? Class, remember this?
Yes, sir.
Yeah.
Okay, V equal to F lambda. So V equal to F lambda. So frequency is 2.5 hertz. Lambda is in centimeter because X in centimeter. So our value also in centimeter. Yeah, lambda is 80 centimeter. You can change it to meter also. Change it to meter, 0.8 divided by 100. So become meter already. So what is this value? 2 meter per second. Okay, because we changed to meter already. And then question D. What's the direction of wave? What's the direction of wave?
To the left.
To the left.
To the left, because positive kx kan. Because there he write positive kx. So that means this is direction to the positive kx. See, positive kx direction wave propagates to the left. The wave go to the left. Right. So positive kx means the wave move to the left. Okay. So positive kx. If negative kx, then the wave move to the right. Yeah. If negative kx, wave move to the right. Positive kx, wave move to the left. Okay. Normally positive is to the right. Positive is to the right, but this one is opposite lah. Opposite. Positive to the left. Positive kx to the left. Okay, so that's all for question 8.